welcome to a brand new video where we today will look at the shader loader. So yeah, let's hop right into it. First of all, we will need a shader class. So let's create it. This is the header file, so primer once. The top, then we make a class that is called shader. And add this in here. Then we add the public tab and the private tab. First of all, we need some sort of knowledge of the path. So for that, we need to include string. Yeah, of course. Include IO stream. This on the the vertex shader path. We're gonna have one for the fragment shader as well. This one we can initialize to be nothing. And then we need a GLU int. GLU int. We would then need to include GLU maybe? Yeah. Which will be the ID of the program. We need a constructor, as always. And I'm not really sure. No, wait, what am I doing? So, the constructor will need to always take a constant char, like a char pointer to the path, and a constant char pointer to the fragment path, like that. And this should be fine. Yep. And then we can say we should be able to destroy our shader. We need to clean it up. We would like to reload the shader, maybe. Aha. And we want to use the shader, so we make a public function for use. And should we do like a connect instead? Or link? Yeah, link. Shader. The dot link. Yeah, I think that is. And then link or just link and unlink. I think that is a better way to say it than use and unuse. Now we need to have some functions for uniforms, and uniforms is some sort of a variable in the code that you can during runtime change from the code. Yeah, but however, how we're gonna set this up is just making a constant string reference that is the name of the uniform in the shader, and we will come to this one later. And we will just have like a lot of these. So here we have the set bool. We will have for like an int as well. So we just change this one. Then we might have for a single float. Say we need a float. And here we can like continue with the like set vec2, for example, and then we need to import GLM here and set the vec2 here. So doing that, we will have it like this, and we can continue here for more or less all of the vectors. So 3, 4. Here we can have mat4 if we want to. I think those are the most common one. For this, so we can space them out a little bit so we see. So here we have the more common one. Here we have the vector ones, and here the matrices. And finally, private. Only one thing here. Load shader. The most important one. And this one is used with the same input as those are. No, as these one are. And to be fair, would probably nah. Not making this one a singleton, that would be very, very bad. But maybe like doing some empty constructor and then just making create and destroy instead. And the crate loads the shader. Maybe a better approach. Can do that as an what you gonna say? Note. Maybe change to create shader instead of constructor. I do actually not know which are the better approach to do it, but we'll see. This series is actually just to try things out and see where we can get with everything, so yeah. That's fun. But well, first of all, we need to include the shader. Then... Now, I did not make a namespace for that one, so I will need to go back and do that. But first of all, let's just do the shader here, and I will be lazy, just going back and getting those. Doing it like this. This one will be very simple, so it will just like load the shader for the width path and the fragment path. More, then we have the private one, load shader, one that is in the heart of everything. Just doing it like this. Ooh, and here comes the fun part. So first of all, we need to make a string that is the content of the files, and the content of the files is those, like those we did last time, because I just made it to files instead. So for the fragment shader, then we will like to need, is this one accepted here? Yes, it is. And we need a reference to the file, I guess. This one I do not really remember. Incomplete type is not allowed. Local variable not initialized. That's okay. I think the next couple lines will fix this. I'm actually not using learn open yield this time. I'm actually doing this with my with help from my own loader from like a year ago. So this is actually my code from the beginning and everything. So that's fun. But it's also, as I said, a year ago. So, but what we are doing now, I'm actually remembering this one. So we're adding some bit mapping to make sure it is handled in the same way we want it to. A bad bit. And this one will be the same for the fragment shader. So now we will try to make this one, and that fails, we catch it. We catch it on if stream. If it's a failure, yeah. So in here we access the shader file and we open it. Well, open. And we open it with a path. Do the same for a fragment shader. And for the fragment path, otherwise we'll have problems. And then we do a stream. Stream string. No, stream for these stream, so we can like stream the content. I don't know how to say it in a good way. To be honest, very happy that not a lot of people look at my videos yet, because like I want these. I still want these videos with me being like not fully certain about things, because I want to learn, and I do these videos just to push myself to learn, not to like make someone be a professional at these kind of things. Maybe watching me doing every wrong step is helping someone else. I don't know, but it's mostly just to push myself to learn, and not having like a big crowd looking makes it easier. So what I'm doing right now is just like putting everything in the correct variable to be read at the be read in the correct way. So for example, I'm right now just getting all of the content of the file from the files from the string stream to the std string with a string conversion, and that will make it possible for me to read out every instruction and send it to the GPU when it's needed. That's what I think, at least I'm doing. It will be a bit clearer when I'm coming up a bit longer down on this. Oh, okay, so now we have the first catch. In this one we will have some more try catches, I think. But here we did not successfully read the file, so we will do some sort of print to say that, hey, yo, this did not work. So say like loading shader files did not load. Now we say like error shader files did not load. And we can say like function. Or did I do any? Window, yeah, I did a kind of, this is how I should write. Yeah. Okay, so starting with this one, thing here, like load the shader, just that, no, shader, and we say that it's an load shader, it's an error, and the message is this one. I don't really like this format. Maybe doing it like this instead. I don't know. This is something I need to fix. I guess this is fine. Yeah. And we do an assert for this one as well. So we crash the program because it should not continue if it did not read the vertex shader, because it will not be able to do anything. So it should be able to read all of the shaders, otherwise we'll get undefined behavior and all of these creepy things. So now we will need to make this constant char, the vertex shader code, the one we set here. This we need to make to do something else. So we wish there. Yes, code dot this one, and then we do that for the fragment shader as well. Then we make some temporarily some IDs for the fragment shader and the vertex shader, and we also want an integer for the success rate. So if we load the shader correctly, the success will be a 1, else it will be a 0, I think, or vice versa, and we will get either an error or not. Or if success is any kind of number higher than 0, I think we have a success. So yeah, could be a bool as well, but I think OpenGL uses an integer, so that's why. We make a char buffer of 512 characters, and we will create the vertex shader by do create shader. This is more or less the same things we did last video. So yeah. Vertex, like that. And then we're gonna say yield shader source is the ID. The amount of shaders, I think, and link to the code, shader code, and null length, so it can be how long it ever wants. Yeah, of course. The info char over here is if we get an error, it will be filled up with that one. But that is the next step after this one. So first of all, we like test so everything works. Now we're gonna check if everything got successfully compiled. So we do get shader IV, and this is like checking so the shader works. So it succeeded. So it passes the ID. We pass it the status we want to check for. So we want to check for the compile status, and we want to pass the success. Here we want to check the success, so if it succeeded, it will skip this. If it did not, then we will check what went wrong. So shader IVNO log, and we want the VSID, we want the buffer size, we want the length width is null, and we want the buffer we had created. I want to printf here, same format as previously. So shader error. Oh. And here we're gonna say compilation failure for vertex shader. Then we'll do a \n error log. We say s, so you get in the string, and then we line break after that, and we pass it the info. So then we get the checking for the shader first. Yep, now we should be able to know what's wrong if something goes wrong, and okay, false. And then we assert, so nothing else like continues. Now we can more or less just like copy paste this one, because now we're gonna do it the same as for the fragment shader. So we do fs on all of the vs, and reuse the same buffer and everything. For this one, just changing for the fragment shader instead. Fragment shader, and then we delete the shaders. No, we need to make the program first. I'm sorry, I jumped ahead. But I think everything should be fine except this one. Of course, this one should be fragment. Like that, and this should be fine. Now, we want to set the ID, this.id, to be the program. So the shader program. We do not need to do this ID, I just for clarity. Then we attach the shaders. So we attach the red shader ID with the ID of the program, and same for the fragment shader. And then we link the program like this. So each shader that we make or load will have its own program, and we will switch between each of the programs by linking the program when it's needed. So now we will just do a final check to check if the program successfully attached or if it linked correctly to the shaders, which I think is more or less just uploading them to the GPU. So we check for the success once again. And I think IV is what we are looking for. The program IV, and then we are going to do the if statement again for the this one. It's fine. Doing it and moving it backwards. And here we have not compilation, we have linking. Linking failure for shader program. And then we have the error log as well here. Continue with sending out the info so we know what's up. Change this one to be the ID instead, so we know what to check for. We want the program info log instead of the shader program log. And now everything should be at the GPU, so we just remove. Just delete shaders. So the vertex ID and the same for the fragment ID. And this is everything for loading them, actually. Now I'm just gonna make a quick implementation for reloading it, because it's handy. So what the reloader will do is just like delete the shader and add it again. So we will just do this.destroy first, and the destroy is not implemented yet, but will be in a second. And then we load the shader again. So we load the shader on the paths that we have saved. So like this. Now I'm just gonna double check. I think this should be fine. Not really sure where I saved those. Oh yeah. Forgot about this one. So we added before in the constructor, just pre-processing it. So when it's so we just do it like this. Fragment shader path is the FS path. So now everything works. Now everything is as it should be. And that's the errors we would have if I wouldn't have noticed that. So just quickly adding the shader destroy. That is very simple thing. Also, we used to yield delete program, passing on the ID, and also here is for clarity, we just do this with ID just to make sure we use just the right one, and then we set this one to an undefined slot. I will just double check so I put the right length. Yeah, awesome. Then we make the linking, so we make a void shader link, and here we do yield use program and ID. Use might be better, to be honest. We use use, and This is like very weird on use. Just asking ChatGPT for a better name than unuse. Give me a better function name than unuse for shader program and use in open. Yeah, of course. Unbind. Use or enable and disable. We just do it like that. I don't know. I will use big letters for now. Might regret it, might change it. So this will then be enabled instead. Work, and here is the same as previously. Then shader disable. I is changing names because I hate and really hate use program 0. I really hate the use and unuse. I think that is what the names they give in the learn open yield, and I'm not really a fan of it ever. But it is fine. The thing we have left now is just to add all of these, but those are very easy to add, so we can add one of them and then I add the rest of video. So we just do the set pool because it's fairly easy. And we just nudge this one to make it go a microsecond faster. Probably not. And here, what did I? Oh, of course. It's a constant like that. Now we just do yield, uniform, on I, and here we set the location, which will be the yield get uniform location, and the ID and the name dot be this. Now we have the location for it, and then we want to int cast the value. So this is how we will do the set bool. Int is more or less the same. We will probably do this one as a separate function. So we will do some sort of load uniforms and put them in a hash table or something, so we easier, or a map, so we can find them a lot easier by just polling the name or the ID. And also here this ID, just to not confuse it in any way. So, but let's try this out. Here, just yeet those away. Will not need it. We can also say goodbye to this one. Yeah. And those as well. Because we don't need them. Not anymore. Now we will instead import the shader here, so we will do include render / shader. Misspelling, like my god. Then we have the shader.h. Nice. Now we just create a shader, which is a new shader, I guess, maybe. Which will have 2 paths. maybe not needing to do a new for this one. This might be good enough. Seem to be. And here I want to do vertex shader. Is that the correct name? We'll try if this one is the correct file path. Should be somewhat correct. Fragment. So just trying to load it, see what we get. When we come to the run, it will assert. I already know that because it will fail on other parts, even if this one works. So nope. Okay. Shader file did not load. So where's the shader? Just gonna with you guys check this one. So we run it from here. So we run it from the debug. So we have the shaders. Oh, shaders, not shader. Shaders. Will this fix everything magically? Or will it now still say that did not load? Did not load, okay. So then it's not dot to dot, it's just a dot. Because now it should work. Or at least find the file. Nope. Why? So we are in the bin file, because this is the root file. Have the shaders, then we have the vertex shade. Why are both the same? That's a problem. Fragment. No, remove that one. Open this one. Double check. Does this now work? Shader file didn't load. Nope. It out again. No, compilation failure. Thank you. Oh. Okay. That is a problem for that one. Now it works. Woohoo! Something still is incorrect because it should not be white. But that I actually know why, because we don't not enable the one, this one. Enable. Do that, but we should do. Now we do. And now it's enabled. We have a we have it where we left off. So that's nice. Cool. 40 minutes video. Whoa. But that was everything for today. Implemented a not quite simple but somewhat simple shader loader, and made it very scalable. And later I will make like a big class of only shaders, which just auto reloads everything and loads everything in the correct order and makes it easier to manage a lot of shaders, because that's a pain in the ass for big projects to manage a lot of shaders, and more or less all shaders should be in some sort of function space. It should be like just a long list of all the shaders, and it's just reloading all of them when it's needed. And compiling all of them when it's needed. But yeah, that's everything for now. Clean the disk code up a lot, and well, this will just make everything easier in the long run. So hope you liked this video. Thanks for watching, and see you in the next one. Bye.